Hello, this is Miss Yochum, and this week we're going to cover ionization. This is a pretty difficult concept, so you might want to take notes or pause the video along the way and go back if you need to. This little cartoon shows two atoms. One of them says, I'm hit, I've lost an electron. And the other one says, are you sure? And he said, I'm positive. This is funny because when an atom loses an electron is negatively charged. So when it loses a negative, it becomes positive. And so that concept is going to be explored today in learning about ionizations. You really need to understand that when an atom gains electrons, it becomes negative. When it loses electrons, it becomes more positive. So this is a review of what we learned last week. We learned that atoms often have an equal number of protons and electrons. If you look here, this particular atom has 3 protons and it has 3 electrons. And when an atom has 3 protons and 3 electrons, those balance out or cancel out and the atom has no charge. When a positive proton cancels out a negative electron, the atom has no overall charge. That's what it says there. But if you were to add an electron to this atom, it would become negative. If you were to take away an electron, it would become more positive because then the positive and negative charges don't balance. We also learned about the octet rule last week. Atoms will gain or lose electrons in order to fill their outer ring with 8 electrons, and that makes them happy. So recall our atom ring rules. The first ring can hold up to 2 electrons, the second ring can hold up to 8 electrons, and the third ring can hold up to 8 electrons. And we know that atoms want full outer rings. Okay, so we definitely know atoms want full outer rings. I better move my movie here so you can see this diagram. So this is a picture of sodium, and sodium has 11 electrons, so 2 in the first ring, 8 in the second, and then it only has 1 in its outer ring. So it's a very unstable, unhappy atom because it wants a full ring, and it's very empty out here. So in order to become more stable, you can think, it would have to gain 7 electrons, and that would be pretty tough to go out and steal 7 electrons like this little guy. So instead, it just loses this 1 outer electron and gives it away. You can think of it that way. It gives it away, and now it's more stable because it has a full outer ring, and that outside ring is gone. But it makes it a positive ion because it has given away a negative electron. So it becomes a positive atom, and we call those ions. A charged atom is an ion, so it's a positive ion now. Now, here is sodium giving away its electron. This is an example of an atom that it might give an electron to, because if you look at this chlorine atom, it has 7 and it only needs 1 more. So they're kind of like a perfect little pair, a perfect little match. Sodium has this outside empty ring with only 1 electron, super unstable, not happy because it's got all this room here. So it wants to get rid of it. And look at chlorine over here, the perfect match, has 7 outer electrons, needs 1 more. So sodium will give its electron to chlorine. Now chlorine has 8, and now sodium has none, and that one ring, its outer ring, which now is this one, is completely full, and they're both more stable. But that makes sodium positive and chlorine negative. And so when we start to learn about bonding, which we will very soon, we will learn opposites attract. And so now these oppositely charged ions are going to stick together and form an atomic bond. And we know that molecule to be sodium chloride, or table salt, the salt that you put on your French fries or food. So that's how table salt forms. Sodium gives a electron to chlorine. Chlorine becomes more stable. Sodium more stable, but they're opposite charged, and so they attract or stick together. So this kind of just reviews really everything that I just said. Sodium has 1 valence electron. Look at this picture. Chlorine needs 1 to fill its ring. So chlorine steals its electron to fill its ring. Both are now more stable because their outer rings are full, but they have opposite charges here. And then those will form a bond later. So now What's down here is kind of important, but I can't see it. The amount of energy it takes to remove an electron is called the ionization energy. So that was the focus of our notes today, is ionization energy. So how much energy it takes to steal this electron to move it over here is called ionization energy. Now for sodium, that's not going to be really difficult to do because sodium wants to get rid of that. It wants to bloop. It doesn't want it in its ring. So it's just going to flick that thing away. That doesn't take much energy at all. But for another atom, let's just even take chlorine, for example. If somebody tried to come steal chlorine's atom, it's going to be like, heck no, I have almost a full ring. I'm not giving any of these up. So it would take a lot more ionization energy to try to steal an electron from chlorine. So some atoms, like sodium, are easy to steal from because they don't really care. They don't want this outer electron. But other atoms are almost full. It's going to be a little bit more difficult to steal from them. So they're going to have what we call a high ionization energy. It takes a lot of energy to remove their electrons. Other atoms, here's my little cartoon that goes with that. So this atom here with almost a full ring has a very high ionization energy. He says, mine, no touchy. You can't have it. So if I try to pull one off of him, it would be really hard. But this one over here with only two, whatever, take one. I want to get rid of them anyway. So they say that has a low ionization energy, or it's very easy to steal an electron from. Okay. So the two types of ions are positive and negative. A positive ion loses electrons, so it becomes positive. A negative ion steals electrons or gains electrons, so it becomes negative. And they do actually have names. A cation is positive, and an anion is a negative ion. And two ions that are opposites will attract to form a bond, which we'll learn later in bonding. Okay, so I do have a Quizlet, which I will link on your Google Classroom, and it's for electron behavior vocabulary, and you can review those terms, and you can play some games on the Quizlet. There's flashcards, there's some matching games. It's kind of fun to use the Quizlet for a review. And I think that about sums up, let's stop. So that sums up our notes on ionization energy. If you have any questions, you can come to live instruction or you can text me. My phone number is on Google Classroom. And I hope you have a good week completing your assignments. And next week's Thanksgiving, so try to get through as much as you can this week.